This summer I was lucky enough to work as a coal geologist intern for Drake Geological Services under the supervision of Mike Drake. He's an alumnus from here who got his geology degree here. He took me in and taught me the ropes of how to explore for coal down in East Texas. So, well, you may ask, why do we do this? Well, I'm sure everybody here uses electricity, so we kind of like that. But we go down and we make sure we can find enough coal for the H.W. Perky plant to keep up and running, keep East Texas with electricity so they can keep their lights on. They like to have approximately a 20-year supply of coal ahead of them so they can keep digging, continuous process. But we go out with the drill crews. We'll pop a hole in a predetermined location and we'll start with a rotary log. I got a rotary bit right here. As the cuttings are coming up through the tube and through the drill stem, we'll look at them to determine if we have enough coal down there, if there's something good down there we want to do what we call a core sample. So we go down with the core bits, and it will actually bring us up a nice core. There's a little holder in there that will keep it in place when we pull it out of the hole. After we get that, we'll actually send it off to a laboratory where they'll test it. They'll test it for sulfides, they'll test it for mercury, any kind of contaminants that the power plant may not want to put into the air if they have to change their scrubber systems. And how we do this, after the hole is drilled, we use something called a geophysical log. We use a radioactive source. Cesium is what we are using. And when it goes down and hits the coal, we can actually see exactly how thick the seams are and if there's going to be any obstacles in the way when the mining equipment comes in. So right there where it peaks out, we can see the coal. When it peaks out to the right real far, we know it's a good clean seam. We can even decide if there's a rock in the way. We have a rock right there which will interfere with the drilling when it does go on. We can determine the amounts of silts, clays, and sands in place for stability. Also, just some examples of what I have here, what I did this summer. We have a rotary log where I am tracking the depth at all times with the drill crew as the cuttings come up, so we know what we have to see if we actually want to core, because coring is $30 a foot when we go down, as compared to rotary, which is only about $2 a foot. So the purpose of the geologist out there identifying what they have down there is also to keep costs down, to make it efficient. And alright, just some of the samples I got, what we were mining out there. We have a piece of lignite coal, what they're burning in their power plants. When we encountered rocks, we have special bits called rock bits out there, made for grinding it, and it saves some of our rotary bits because it'll take the tips right off of them to get into the hard rock. Just a smaller style of bit for when we do rotary. This one here is for the core. We do encounter some unusual things in the ground, like faults will come into cliff embankments. We'll also come into like river basins. The coal will actually die off, and we have to map that out for them so they know not to dig there and save themselves millions of dollars when it comes to bringing it out of the earth. But an example of something unique we found, this is called a growth fault or a slick and slide. The sediments actually cause things to disconform and the coal to end up somewhere else where it wasn't supposed to be. What I have here, this is a sample bag, what we send off to the lab to go get, when we actually get the cores out of the ground and clean them up. And something we look for too to help find the coal, we have what's called carbonaceous clay. It will actually burn, but the ash content is so high they don't want to have to worry about that in the power plant. So we try to hit the borderline where the carbonaceous clay actually meets the good clean lignite. But that is about all I have on coal geology and exploration. Are there any questions?
Where exactly were you in East Texas?
A little town, or close to a little town called Marshall. So what we did was a 10-day drill period out there. It's 10 days on, 4 days off. So, and right now the exploration is good down there. We have about 20 to 30 years of exploration left for this mine company. So we're trying to find them good 30-to-1 overburden ratios, where for every foot of coal, there's less than 30 foot of overburden they have to remove to make it economical. The pay's not too bad. Contract work is in between $750 and $1,200 a day for the geologist himself. With operating costs, depending on your diet, $15 to $20 a day, or your helper, you get paid for it. So.